So students, today we will learn how to draw the MO picture for B2, C2 and N2. In our last class, we have learned how to draw the MO picture for oxygen and fluorine, O2 and F2. And there I have told you that there will be no sp interaction between the 2s and 2p orbitals, atomic orbitals of oxygen and fluorine. But here in case of boron, carbon and nitrogen, there will be sp interaction. And why that is so, that also I have explained you, but still let me tell you once more. So you look at this energy diagram here. This is potential energy versus atomic number. Here you can see that this is the energy of 2s orbital and this is the energy of 2p orbital. In case of boron, carbon and nitrogen, you see the energy difference between this 2s and 2p orbital is less. But in case of oxygen and fluorine, the energy difference is more. So there is no interaction in oxygen and fluorine, but in case of boron, carbon, nitrogen, there is a interaction between the s and p orbitals. Here also you can see this is the plot of delta E versus atomic number, where delta E is the energy difference between the NP and NS orbital, and here you can see this is increasing, the energy difference increases as the atomic number increases. So for example, I have written here delta E for boron is only 2.5 electron volt, while that of for fluorine it is 20.5 electron volt. So you can understand the difference, and in that is the reason why in case of oxygen and fluorine there is no sp interaction. So for drawing the MO picture, first you have to know the electronic configuration of boron, carbon and nitrogen. The configurations are: for boron 1s2 2s2 2p1, for carbon it is 2s2 2p2, and for nitrogen this is 2s2 2p3. And now what are the orbitals involved here? 1s, 2s and 2p, and among them 2s and 2p are the valence shells. So we will consider the interaction between these two orbitals while drawing the MO picture. So now first we will write the 2s atomic orbital for these atoms, like for boron or carbon or nitrogen, the 2s orbital. First we are drawing the 2s atomic orbitals. Now we will write the 2p atomic orbitals, 2p, and in this side also we will have 2p. Now what will happen? The sp interaction, and this will give rise to 2 sp orbitals. So let us first write these 2 sp orbitals. 1s and 1p will interact to give rise to 2 sp orbitals. How these interactions are taking place, that we will see. Like there is a p component and there is a s component, and again there is a p component and a s component. This will give rise to spx1 and spx2. Now in this side also you will have interaction between s and p. So this is the p contribution and this is the contribution from s, and again there will be another one, p and s, and this will give rise to spx1 and spx2, and these p orbitals will remain as it is. This will be 2p y and z, 2p y and z. So why I have taken px for the interaction? Because we have considered x axis as the molecular axis. That's why we have kept py to py and z for pi interactions, and this px will be for sigma interaction. Now how they will form the MOs? Let us draw that. These two spx1 will combine to form one sigma orbital and one antibonding sigma star orbital. So these two are, this is sigma spx1 and sigma star spx1. These two has formed. Now this spx2, they will also form two, one antibonding and another bonding orbital. You have to remember always how to draw these MOs stepwise. So these two, this will give, this is sigma SPX2 and this is sigma star SPX2. Now the pi bonding. So pi orbitals will be formed by 2p y and z. So this is pi antibonding and pi bonding will be here. So this is pi star 2p y z and this is pi 2p y and z. Now you have to show the energy axis here, and in between you have to write molecular orbital of B2C2 or N2, anyone. Now we have to fill up the electrons. We will start from boron. So boron has 2s2 2p1. So we will put 2 electrons here and in p 1 electron. In 2s 2 electrons and in p 1 electron. So what will happen? These 2 electrons will now come to this SPX1 and in the MO they will be filled up, like in sigma orbital you will have 2 electrons and in sigma star you will have 2 electrons. Now this p1 electron, this will come here and in SPX2 another electron. So where they will go? They will go to this pi orbitals. So what will happen? These are energetically, these orbitals are same. So now you see, in case of boron you have 2 unpaired electrons. So boron is paramagnetic by 2 unpaired electron. And now similarly if we do it for carbon, you will have another electron in this p orbital, 2p2 configuration. So electrons will come here. Okay, now so what will happen? These pi electrons, they will be paired up. So you see, in case of carbon you have all the electrons are paired up and carbon is diamagnetic in nature. Similarly, when we go for p3 configuration, that is for nitrogen, another electron goes here, another electron goes here. So what will happen? This electron will go after SPX2, this will go to this p orbital, and where these 2 electrons will come? These 2 electrons will come to this sigma orbital and they will be paired up. So in nitrogen also you have all the electrons paired up. So nitrogen is also diamagnetic in nature. So this is about the magnetism. Now we will write the electronic configuration, that is MO electronic configuration of these molecules. A general configuration I will write. Then we will calculate the bond order for these molecules. So first let me write sigma SPX1, then sigma star SPX1, and after that there will be pi so pi to py nearly equal to pi to pz, then comes sigma SPX2, then comes pi star to py nearly equal to pi star to pz, then sigma star SPX2. So this will be the arrangement of the molecular orbitals. Now filling up of the electrons. Like for boron, we had 2 electrons in SPX1, 2 electrons in sigma star, 2 electron was in sigma orbital, 2 electrons were in sigma star orbital. Then in both the pi orbitals we had 1 and 1 electron. So what will be the bond order? So bond order is equal to number of bonding electron is 2 plus 3 plus 4. So 4 minus 2 in antibonding orbital divided by 2 is equal to 1. So bond order for boron is 1. Then in B2. And then in C2 we had, you see, these pi electrons will be paired up. So we have bond order is equal to 2 plus 2 plus 2, that means 6 minus 2 divided by 2 is equal to 2. That means in C2 we have the bond order is equal to 2, and in N2 bond order is equal to, you see here you will have 2 more electrons. So you will have 8 minus 2 divided by 2 is equal to 6 by 2, that means 3. The bond order is 3 in N2. So you can say that the bond order in B2 is 1, in C2 is 2, and in N2 it is 3. So I am sure now that you will be able to draw the molecular orbital for B2, C2 and N2, and you will be also able to calculate the bond order for them, and also you will be able to tell about the magnetism of these molecules.